Hi, hello. Today I would like to demonstrate a problem with XDP DDoS SYNPROXY acceleration with iptables SYNPROXY module. So one user reported to me when they use bpfire or use XDP SYNPROXY acceleration for their web server DDoS protection, they experienced slow website loading. So when user browse their website, the browser is very slow to load the web page. And I can reproduce the same problem through this website. So in this website, you can launch collection to your web server through different countries or regions all over the world. So this is a good way to test your web server, if your web server is responding quickly or not. Yeah. So I reproduced the same issue through this website testing, and for example, the problem here is that when I enabled the XDP SYNPROXY acceleration with iptables SYNPROXY, the server will start to send a small packet to the browser or to the client. You can see here in this screenshot capture, here this blue, it shows the packet size for each frame, and it's like 278, 501, and 1 byte here, and yeah, so it sends a smaller packet, and then it causes the web browser slowly loading the web page. This is a problem, right? So how we should solve this problem? And so, for example, here is my web server. Right now, I don't have anything, any protection here. For example, let's check iptable rules 443. So we will protect the 443. There's no iptable SYNPROXY rules for port 443. And there is no XDP acceleration. No XDP program attached to this interface, this web-facing interface. Okay, no XDP here. And yeah, so let's do a test for this for this no protection website. And let's send a request here. So the website I'm testing is encrypted www.bpfire.net. So we can see here is the latency, and so most of them is under 1 second. Some of them are about 1 second delay, and which is normal because the web server is located in Singapore data center. So those collections are across all over the world. So there is one like from Iran, it's a 3.6 second, which seems normal, and yeah. So under 1 second or about 1 second, right? So this is the web server has no any collection or any protections. Now let's do let's enable the SYNPROXY iptable the SYNPROXY module and without XDP. So here's a way to set up the iptable SYNPROXY module for DDoS protection. So this is the one, iptables with jump to the SYNPROXY module, and this is TCP options. for the SYNPROXY module to generate a sync cookie and validate the sync cookie under DDoS flood. So let's run this bash script to enable SYNPROXY protection. Okay, so we have iptable rules here now with one iptable rule in the pre-routing chain in raw filter, in raw table, and one is input rule in the filter table for SYNPROXY. Okay, so remember there's no XDP acceleration, so no XDP involved so far. Okay, so no XDP program attached. Now let's do a latency test again. So do you notice the difference here now? There is like a 5 second here from the UK and from US. There's 5 second delay, 4 second delay. One in Turkey, from Turkey, is a almost 7 second delay, right? So those delays are significant, and this is only when I enabled the iptable SYNPROXY protection, right? No XDP acceleration. There is like a 4 or 5 second delay. Some of them are still under 1 second. Some of them are about 1 second delay. But some locations like US, UK, 5 seconds. Now let's enable the XDP acceleration. So for XDP for the iptable SYNPROXY. So this is how I run the. This is how I add the XDP acceleration here. So this XDP SYNPROXY will load and attach the XDP program to the interface 0, ETH0, and this is a TCP options. And pay attention to this here. I use the WinScale 7, which is enable the TCP option window scaling with 7, and for port 443. Okay. So now we have XDP acceleration enabled. Now let's do a latency test again. So we can see here there is like a 4 second delay, 5 second delay, like from Iran. Let's ignore Iran for now. But this is from Netherlands, 6 second delay, Turkey, 6 second delay, US, Ukraine, 4 or 5 second delay. For Starlink, for SpaceX Starlink. Yeah, Starlink, this is a 7 second delay, 7.5 second delay. So with XDP acceleration, it seems did not improve, or actually even worse, right? Now let's stop this XDP acceleration and let's run this way. Let's give a Windows scale value 0, which is to disable the window scaling and the timestamp option. Because this is I changed the code. to allow disable the window scale and the timestamp options, and let's see how it goes. Okay, so now no window scale, no timestamp TCP options. Let's do the latency test again. Did you notice? Now it is better, right? After I disabled the window scaling TCP options in the XDP program, in the XDP generated sync cookie. The SYNAC, not SYNAC, the sync cookie. So the sync cookie is encoded from the client TCP options. So this does not reduce the security of the sync cookie, because the sync cookie is generated based on the client TCP options, IP address, and other stuff. This disable window scale TCP option and the timestamp option is for the SYNAC send it to the client. And now we have better result. So some of them about 1 second. Like here is in India, it's close to Singapore, only 0.2 second. And we don't see 4 or 5 second delay, right? And so the biggest one here is the Turkey, which is a 6 second delay previously. Now it's 2 second delay. And the US, previous is 5 second. Now it's about 1 second. So it seems becomes normal, right? So this improves a lot. We can see it is working because whenever we start a new test, the SYNAC generate the SYNAC number increased. So here is the SYNAC I'm talking about. Like when a client sends a SYN packet to the server, the XDP will generate the SYNAC and with TCP options. So here I disable window scale. So in the SYNAC, there will be no window scale options, no timestamp options, only MSS options. But if I run window scale with a 7, which is you label the window scale option in the SYNAC, and the latency is not good. Yeah. So what does this tell us? So what does this tell us is remember when I just labeled the iptable SYNPROXY with no XDP involved, we observed the 4 or 5 second delay, right? And the problem is the same when we labeled the iptable SYNPROXY. The server started to send the small packet to the client, and it has to be reassembled. Like this small packet is actually the server SSO server hello, which happen to have a big payload over 1,500 bytes. Yeah. So the problem is with or without XDP, there is a latency for iptable SYNPROXY modules. So I think the problem is from my understanding is the iptables SYNPROXY module. But I'm curious though that this SYNPROXY module has been developed very long time ago, and I'm sure people are using it, but so far I have not seen anybody reporting the problem here with the latency. So this is the issue I report and recorded here under my clone under my XDP tools clone. And yeah, so but the good news is we can use we can disable the window scale and to achieve the same result when no protection enabled for the web server. And yeah. And also I have fixed this in the BP file. In the BP file image. So yeah, I fixed it. So adjust the program to like in this DDoS script, which is to load the XDP program, and I set the window scale to 0. So when you get a BP file installation image, you will have the working code to solve the latency issue. Okay, so yeah, I'll continue to. I already report the issue to the let filter group, user group, and probably needed to send it to the developer group to see why there is a latency for some locations. Okay, thanks for watching.